All right, welcome back, and let's jump into the first lecture. So this is going to be foundational knowledge about psychology, and psychology, the development of psychology, history, where we are today, and psychological research. So to get started, think about today's goals. So I'll define psychology. Again, talk about that history, different fields in psychology, and talk about why psychology is weird and the scientific method. These are some learning objectives. I think it can kind of serve as a guide, but I won't go into information about all of these, but it can kind of just give you a little bit of an overview. If nothing else sticks with you over this entire course, especially today's lecture, this is a really key one to recognize what is psychology. This is a big take-home message. If a family member or a friend asks you about it at Thanksgiving, any other time, you'll know how to answer them and to summarize the class that you've been taking. Psychology is the scientific study of the mind and behavior. Each part of this definition, I think, is really important and summarizes the whole course and the whole field of psychology. So it is a scientific study, right? We're constantly learning, changing what we've previously thought, gaining new knowledge, rejecting things that we've believed in the past. It's constantly evolving, right? Similar to physics, astronomy. Researchers in those fields used to think that the sun revolved around the Earth. But now we know that the Earth revolves around the sun, right? They did more research, they tested more things, we flew to outer space, we gained new technology, we learned new things. So they updated textbooks. We've done the same thing, right? Textbooks would have looked so different about psychology in the past, but now we have new information. We have brain scans. We have new measurements and tests to study psychology. And so textbooks get updated. We change our theories. What are we studying? We are studying the mind and behavior. The mind are things we cannot see. Behaviors are what we observe. So if we're thinking about the mind, it's things that we, right? If you were a mind reader, you would be able to understand, like, what are our thoughts? What are our internal emotions? I can observe that someone is crying, but maybe I don't know if they're crying because they're happy or if they're crying because they're sad. I could use context. Maybe they just won the lottery. So they're probably crying because they're happy. I could ask them why they're crying, what's going on in their mind, and they can tell me. But I can't know what's going on in someone's mind without additional information. But I can observe behaviors. I can observe someone crying. I could observe someone being aggressive. But I don't know if they're aggressive because they're responding for safety with defense. I don't know if they're being an aggressor. I don't know if there is uh, some other reason that someone is being aggressive. But I could ask or use context. This is what we study in psychology, thinking about why people think and do what they think and do, trying to understand what truths there are about all people, and there are different domains and different fields that people study to try and understand these concepts. And that's what we'll talk about today. first, thinking about the history. So, how did we get to where we are? These are the first kind of early steps and ways that people thought about psychology. So initially, there was this kind of battle between, and this is in the 1800s, people were fighting between structuralism and functionalism. I'll just jump to this next slide talking about Wundt, who was our first psychologist and was a structuralist. He was trained in medicine and physiology. So physiology is kind of the study of bodies, and so that led him to want to understand vision and smell and these senses, analyzing sensations, images, and feelings, putting them into their most basic elements to understand consciousness. Well, if someone sees something, what do they do about it? If I see an apple, is it red? That's probably safe. I'll probably go eat that apple. Does it smell fine? How do I even visualize and recognize that something is an apple? What is an apple? How do I know that it's still an apple? These were kind of the psychological processes that Wundt proposed and recognized. But functionalists, such as William James, said that is no good. Humans are way too complex to be thinking about things in a structural sense, just piece by piece. We need to think about things in a functional sense, thinking about them especially in terms of evolution. Well, if I recognize that's an apple, what are all the processes that are going to be going through my mind? I am hungry. I recognize that my body is signaling that it is hungry. I think that. So that's going to inform my behavior, which is to look for safe food that is the appropriate color, that smells fine, that has a good taste, that will enable my survival, right? So it is essential that I eat and drink. So that's going to influence my behavior to seek out things to fill those needs so that I survive. So functionalists are thinking, how are all these systems working together as mental processes to make decisions? G. Stanley Hall is another person who is probably important to remember. He is the first psychologist in the United States, starting a research lab. He, again, believed in this field of functionalism. You can see his name in the summary there. And you can remember his name as well. Gestalt psychology is a kind of specific form of this functional psychology. It rejects structuralism. It specifically says that the whole is greater than the sum of the parts. Right? So again, core idea here, we're thinking about how was psychology developed? What did we begin to learn? Right? And structuralists were saying, well, if language is this step by step, piece by piece system, a structuralist would be saying, I need to know every single letter that is in every word because that's the basic that's the basic way to read. I read letters, letters compose words, so I need to read each letter. Well, there's something way bigger going on in our language capacity, not just recognizing letters. So Gestalt psychologists point out we can read this because there's something bigger going on. The whole is greater than the sum of the parts. We have so many language parts. We have vision. We have language centers that can recognize these words and what they're intended to mean. And all of these things work together to make this even greater capacity. Here's another example of Gestalt theory. So it explores the idea that although a sensory experience can be broken down into individual parts, right? So there's vision, there is your emotion with it, your previous experiences. Each piece can be broken down, but to recognize this invisible triangle, you can still see it because those individual parts are working together and creating something even new and even better, even more powerful, that allows us to see beyond just those individual parts and create this entire perception. And here is the next step that kind of leads us to a little more of a modern psychology. So Freud is kind of maybe the uh, final founder of psychology, perhaps, by way of kind of creating this developmental psychology, a theory on personality, and intervention for mental illnesses. He was really interested in the unconscious. We'll talk about him in a lot more detail. He created really controversial theories, some of which we agree with, some of which we don't today. But the point is, he created so much foundation for psychology. A lot of his stuff is found in the work that others have done. This kind of leads to the more modern way that we think about psychology, which led to the next school, which is behaviorism. Behaviorism recognized observations. They didn't care about what you were thinking about. They just wanted to see what you were doing, how your behaviors were leading, were based, how psychology is based on your behaviors. And so a couple of their key ideas, led by Watson and Skinner, are thinking about what, as a psychologist, what would I observe an animal or a human doing? How can I control these behaviors? So we'll talk about conditioning. You can think about things like reinforcement and punishment. If I give someone candy, they'll probably keep doing that thing. Or if I punish someone, they'll probably stop doing that thing. So that's kind of the key idea about behaviorism. What is the act? How can I change that behavior in someone? But behaviorists didn't care about what you were thinking, how you were feeling. They just only cared about what was observable. Humanists came a little bit later, and Maslow, Carl Rogers were key figures here. And this is getting more modern, right? But the field is still so young. These movements are still developing. But thinking about, as humans, what are our psychological differences, right? Like you could technically study psychology of certain animals, but what is the psychology of humans that is unique and different? So all animals, all living things have physiological needs, food, water, shelter, security needs. They're going to be scanning their environment, making sure that they're safe. Most animals have these social needs, that you have this need to belong, this companionship, this desire to produce offspring. And then these more uniquely human needs, self-esteem, accomplishment. And he proposed that there was this self-actualization, that once you could kind of maintain all those other things and that you were safe, you had all your basic needs met, you could achieve this self-actualization, this fulfillment. And then a cognitive field developed. They said, well, behaviorism is great, but hey, we also think there are things going on in the mind that are also important. And even though we can't observe them, we can still think about them and research them, including memory, cognition, language. You can't observe memory. I can't see what your memories are, but they're impacting how you're behaving. If you have a memory about uh, something really positive. If you have positive memories about school, you might really like school. If you have negative memories, you might not want to go to school, or you were getting bullied at school. So you have kind of those negative experiences. So you're always stressed. That leads to behaviors of avoidance. Those memories, those internal things, are going to be impacting your behaviors, those observable things. And that is the point that cognitive psychologists make. That is our history, right? There are these different perspectives, different fields of psychology. They're not so distinct. People nowadays kind of believe several of these things are important. This was kind of the trajectory of how things developed. So we say, okay, there's these sort of developmental experiences and these personality components that are important for how people behave, which we can observe. Their mental processes are impacting how they're behaving. And there's these uniquely human things too, right? So these are all kind of collected. Some things are still supported, some things are kind of rejected. These are basic schools of thought that have led to where we are today. This is a guess and check, kind of a way to test yourself to see if you have kind of retained that information about these schools of thought. For example, the most important thing in explaining a person's behavior is how they think and process information. So that thinking, cognition, that should lead you right to this cognitive school. Go ahead and test yourself, think about um, some more of these. One of these that you can see the answers in the slideshow, which you can download. One of these that wasn't discussed in the previous slides is biological. So now that we have new ways to study and new tests, we can kind of test genetics and hormones and things like that. So, for example, number 3, brain chemistry and hormones have a huge impact on behavior. That's going to be biological because that is even an additional step. What does it mean to be weird? Psychology is weird because the bulk of studies conducted in the field have been done in countries that are basically Europe, the United States, Canada. They are countries that are Western, educated, industrialized, rich, and democratic. That means that we need to continue doing research, right? A lot of the research that has been done in the 20s, 30s, 40s, 50s, 60s, all of the foundational research was done with white people. A lot of times they're done in college students. They're not necessarily representative of the population, whether that's the population of the US, the population of the world. Most of the research done has been with a small subsample of the population. That leads to cultural bias, ethical concerns, right? If we are saying that a certain treatment should be done for all people, but it's only been studied in white males in the US, maybe it's unethical to bring that treatment to South America or Africa, or maybe even women in the US. So it limits the ability to bring those findings more universally. Now, having established kind of what the history is like, we will think about 5 psychological domains. So this is coming from the textbook. There are these 5 key domains, and this basically is all of the content that we'll talk about in the course. Each of these kind of corresponds to 1 or 2 weeks that we'll talk about. So for example, under the biological domain, we will talk about biopsychology, sensation, consciousness. We will break each of these subjects into kind of week by week, thinking about cognitive, developmental, social and personality, and then mental and physical health. So I don't need to go into too much information yet, because we're literally going to go through each of these, but this will just be a little bit of an overview to get you familiar with where we're headed. So biopsychology, right? We study psychology, which is the way that mental processes and behaviors show up, but we believe that that is influenced by our brain and by biology. So we study that combination, right? Neuroscience would only look at what are the literal processes that are happening in the brain. Where is it at in the brain? Can I determine if a certain region of the brain is important in this process? Biopsychology kind of looks at that combination, right? There's neuropsychology. What is the behavior associated with the whole function of the brain? Or thinking about even less specifically in the brain, maybe like hormones. Do certain hormones affect behavior, mood, emotion, that sort of thing? Evolutionary psychology thinks about how this behavior has evolved, why we do certain behaviors, and a lot of it comes down to, from their perspective, doing things because it leads to safety. Sensation and perception are these kind of more biological things too. So thinking about, well, I'm seeing something, I'm internalizing that in my brain, and that is going to lead to certain future behaviors. All of our sensory systems will work that way. Cognitive domain. So this is things that are internal. We can't observe them directly. And so that's going to be things like cognition, memory, intelligence, things that might be associated with these behaviors. We're just going to measure what is the mental process that's going on. Developmental. How are things changing over time, right? Does puberty lead to new types of behaviors and thoughts? We also talk about classical operant conditioning. We'll get into a lot of that, but that's like learning. If I am punishing you for, if a parent is punishing their child for not finishing a chore, they lose screen time. The child is going to learn, if I don't do my chore, I lose screen time. They will then internalize that and change that behavior. So that's kind of this developmental. That can be teaching, education. All that is going to depend on development. So we think about how our behaviors and mental processes changing over time. I mean, as your brain develops, you are gaining better ability to control your impulses. You have greater capacity for math. All of these things are going to impact how you are able to interact with the world, take that information as mental processes and behaviors. Social and personality psychology. So these are going to be, it's important kind of to distinguish here the difference between sociology and social psychology. Social psychology is focused on the individual, whereas sociology is focused on systems or groups of people. So if I'm an individual in a group, how is my behavior impacting the group and being impacted by the group? So if I'm a great leader, how is that changing the group dynamic? Or if I'm a troublemaker, how does that influence others? How does that impact my family? That's going to be kind of looking at the individual. How are they impacted by, and how do they impact others? Personality psychology is going to be how does the individual act, and what are kind of the consistent things, and how would you describe someone? So is a person thoughtful, outgoing? There are different theories about what this looks like, how stable it is, does it change? Does it change with time? Can it change at all? So we'll talk plenty about that. And then the last domain is mental and physical health. This is about mental disorders. So abnormal psychology is going to be about psychopathology, is about differences, things that cause problems. So if you think about depression, anxiety, ADHD, schizophrenia, these things might cause problems for people, and so they might seek help and they might get a diagnosis. So that's kind of where clinical psychology comes in. That's my area of specialty. And a clinical psychologist might diagnose and then treat with therapy, some other methods. Of course, there could also be medication that could serve as a treatment for psychological disorders. And then health psychology is going to interact with biological and psychological factors, thinking about physical health as well, right? So you think about if you go running, you get positive endorphins that can make you feel happier. If something with your health is causing problems, that all these things can kind of interact. If you're really stressed, that might lead to negative symptoms in your body as well. So that might impact your psychology. If you're in an unsafe neighborhood, that might be a social factor that is impacting psychology. You feel always at danger, kind of on edge, and that could impact your biology as well. Maybe you would really like to go on bike rides or walks or runs, but you can't go outside because it's not safe. So all those factors are going to impact one another. There are additional fields just to highlight. If you have an interest, feel free to look into these, but they're not really the core to the class. But there are other things. Industrial, organizational are going to be business related. You think about management, ways to make businesses more successful in organizations. Forensic psychology, that's going to apply science and the practice of psychology to the justice system. So if you think about, there are forensic psychologists who will go on stand to defend a client that is has done a crime, but maybe they're pleading insanity. They weren't responsible because they had psychosis or something else was going on. It wasn't them, it was a mental condition that forensic psychologists might argue for that reason. Sport and exercise psychologists, another subdiscipline. Maybe you're interested in athletes and how to improve motivation or emotion related to exercises, or like you might work for a sports team in order to get them really excited about um, a team that they're playing, or figure out ways to improve when they at what time they're exercising, when that peak time would be based on psychology, or um, time of day, and all these factors that might be impacting their performance. Why study psychology? So this is just a slide to kind of help you think about, even if you don't want to be a psychologist, which could be so many things, you can find psychology everywhere. And this kind of relates to this assignment that you'll be doing for the discussion, which is to find psychology out there in the world. Psychology is everywhere, and right, it's in every sector, whether it's business, medical things, whether you want to be a teacher, whether you want to be a nurse. At any institution, you will find psychologists and find psychologist work. So you can apply that to your own area of interest, whether you want to be a psychologist or whether you might in the future work with psychologists. And if you were to get a psychology degree, you could find jobs in really any situation, right? You could be doing therapy, you could be doing research for an organization to help their marketing campaign, uh, figuring out, like, say you work in real estate, where is the most likely area that people are going to be seeking to buy houses? What factors make them feel safe in an area? If you want to set up a house when you're trying to sell it, what are the factors that are going to make it look the most pleasant for someone? How are you going to market that? So you can find psychologists all over any industry. And that brings us to research. If all of the things that I have said have felt confusing or unimportant or uninteresting, stick with it. We will kind of go into each topic in more detail. This is just a broad overview. Feel free to ask questions. But I think some of the key takeaways are that there's a history of the field. There's so many areas that psychologists study. And that leads us to here, which is to say, this is how they study it. Like, how is any of the stuff that we know true? Well, they've designed research studies that help us find these kind of objective truths. So I'll talk about what that process looks like. It's pretty general for a lot of the sciences, but because we're working with people, there are some differences that are important to recognize. Some of those differences are about how we design certain experiments and also ethics, right? Like a uh, chemist doesn't have to think about the potential ethics of the chemicals that they're working with. A psychologist has to think about, well, I can't harm any of the people that I'm doing research with. So that's kind of an important distinction that makes psychology research unique. So, like all these other fields, we follow the scientific method. The scientific method ensures that results are empirical, meaning they're grounded in objective, tangible evidence that can be observed time and time again, regardless of who is observing. So again, all these pieces are important in this definition, saying they're objective. They are not biased. They are not based on what someone believes, they're tested. And we have evidence that we have tangible evidence that we can show someone as data, and they can be observed time and time again. So we can recreate this study, and the same thing will happen, regardless of who is observing. This is what that scientific research process looks like, right? And this is the same for any scientific field. That's true for chemistry, right? If you take two different kinds of chemicals, you put them together, what happens? Does it explode? Does it make a certain color? What am I observing? What can I take away? What are the results? And you'd have a hypothesis, right? If you put water with Gatorade, what is going to happen? Well, it's gonna make this Gatorade more watery. It's gonna reduce the color because it will reduce the intensity of the color, right? You can add in all these pieces to make it an official experiment that you can test again and again. So maybe you start by making an observation. Something is interesting, so you ask a research question about it. What would be an observation? And I'm going to go to this next slide and then come back. An observation is a careful examination of the real world. So what might I make an observation about, right? I'm a professor, and I observe that students who seem to study seem to do better in the class. They have a better final grade. They get better homework points, they get better exam scores. The students who study seem to do better. So what's my question? Well, I gotta test that. Is that even true? Or is that something just a professor would like to think? So I asked the question, do students perform better if they study? First step, form a hypothesis that answers the question. A hypothesis is a tentative and testable statement about the relationship between two or more variables. I think studying relates to the outcome of that student in the class. There's some relationship between studying and grade in the class. Then I'll make a prediction. I think that more studying will lead to an improved grade. That's kind of broad, though. How much studying? Is there a certain amount? And how do I know? Like, is it maybe the case that students in the past that have studied are really motivated, so they study a lot and they do well? Or do they just have a natural smart intelligence that helps them do well? So what's kind of the reason for that going on? Well, let me design a full experiment. I'll take 100 students in my class, and I'll say 1/3 of them, I'll say they shouldn't study at all. I'll tell them not to study. They study for 0 minutes, 0 hours. I'll take another third and I'll say, you guys, I want you to study 2 hours each week. And I'll take the last third and I'll say, you guys study 10 hours. And then I'll compare how each group does at the end of the class. So I can say, there are those 3 groups, study 0, 2 hours, and 10 hours. So maybe 0 is not enough, but 10 is too much. Maybe you're burnt out. So I think maybe 2 hours is just right. So I'll test it. I'll say, I predict that studying for 2 hours will lead to the best outcome for these students. I'll analyze the results. Maybe I was right. If I say I think 2 hours is the best, but I was wrong, all the 2-hour students failed. Well, then I need to go back and make a new hypothesis. Maybe it's not 2 hours, maybe it's 3 hours or 1 hour. Or maybe it's not even about the number of hours, maybe it's about quality. Are they in a quiet space when they're studying? We can design so many studies to figure out the exact way to improve these kind of outcomes. And maybe information kind of depends on who. Maybe boys study better when they're listening to music, but girls study better when they're listening to no noise or they have TV on in the background, right? We can kind of test those things too to figure out truths about behavior. A theory is a well-developed set of ideas that propose an explanation for observed phenomena. So a theory could be just a broader takeaway on a larger set of a psychological idea. So I might say studying leads to positive outcomes. That's super broad, but I can kind of test individual smaller things, right? I can test, is music helpful during studying? Is it helpful more for boys or for girls? Is it the number of hours? And I can create specific hypotheses based on each of those. So I use that theory to form a hypothesis. I have this theory. There's research articles on it. Other studies have been done showing that studying leads to positive outcomes for students. Let me test that in first graders. Let me test it in second graders. Let me test it for math versus reading. Then I design a study to test that hypothesis, do the study, and make an observation, make a conclusion. So maybe then I create or modify the theory. So the theory said studying leads to positive test grades, but that wasn't true if you only study for 1 hour. So now the theory is studying for at least 1 hour leads to positive test grades. So that is kind of this scientific process applied to psychology. And here are some more examples if you want to test yourself. What would be the hypothesis? What is a potential outcome? Ethics are extremely important for psychological research. You shouldn't have, no one should ever have done unethical research, but unethical research has been done. So in response to that, there have been things put in place so that people don't do more unethical research. This key step is the Institutional Review Board, the IRB, which is set up at every university. Anywhere that does research anywhere that does human-related research has to go through the IRB. So I'm a graduate student. If I want to run a study to gather data, or if any psychological researcher wants to run a study, they first pass it through their IRB. They say, hey, I have this study idea. Here's my hypothesis. Here's my plan. I want to gather 100 participants and I'll pay them. And I want to observe sleep and how that impacts test performance. And the researcher would say, okay, that looks good. But what if I wanted to keep them awake for 10 days? I wouldn't let them sleep. And I wanted to see if that would impact their test performance. The IRB should say, that is cruel. You can't do that. But the IRB has come out of things that have been done have been done unethically. So now you need to add in certain things that say, you need to give them informed consent. So if I'm keeping them up for one night, which is probably not unethical, I would keep them up. I would make sure they don't fall asleep, bang drums, whatever it is. Keep them awake for one night to see how it affects their test performance. But I give them informed consent. I say, I'm going to keep you up for this night. If you don't want to do that, you don't have to. And I can't coerce them either. I can't give them so much compensation that they might do something that might harm them. I can't give them $2,000 for keeping them awake for one night. It should be reasonable for what you're asking them to do. Maybe like $20 per hour. Something sort of reasonable that compensates them for their time and effort, but is not unreasonable to coerce people. You explain the risks so that it might be boring or might make them very tired, and but also the benefits kind of either to them specifically or to society, that it will be really helpful for society to know how sleep affects tests, right? Or something even more beneficial. In some cases, we need deception because we're doing something that we can't tell them specifically about. So an example of this might be something related to uh, behaviors. An example could be, we want to see if an individual helps a stranger. That just happens to be on a street that they're on. So we conduct a study and we want to see if a stranger who is asking for $1, if the participant will give it to them. We sort of mislead them by saying, we just want to see how you walk. We want to see your walking behavior, like the rate of speed that you walk down a street. We have to deceive them because if we told them that we wanted to see if they will help a stranger, they probably would help the stranger. So we wouldn't know what factors would influence that, right? Maybe we want to see if men versus women help more strangers, but we can't tell them that. So we would say, we just want to see how you're walking. So in that case, we would have to use deception, but it's not unreasonable to conduct that experiment. And just tell them afterwards. We're able to debrief them, give them truth afterwards, even though there was some deception involved. Now, getting into this kind of nitty-gritty different types of research. These are not extremely important things to take away from a general psychology class. These are things that can be useful when analyzing research or just being a smart uh, consumer of knowledge. I think um, it just makes you a little more informed about how these studies are being done and also things to watch out for. So let me jump into it. But again, if some of this is confusing, it's not extremely important that at this point you learn how to design your own study, but it's just general information that can be helpful to recognize as we're talking about these studies and how this knowledge has been gained so far. There are going to be 3 different types of research: descriptive, experimental, and correlational. So we'll start with descriptive, right? These are just describing what you have seen. These can take place as clinical or case studies, right? So as a therapist, I might see a family. Maybe I observe that uh, females have more depression. Just based on, I have 5 patients. uh, four of them have depression, and 3 of them are female. Seems like maybe more females have depression. That's not super compelling because there's not a lot of information. Maybe if I had 100 patients, I would see that it's a 50-50 split between men and women. You can also do naturalistic observations, not designing something like the stranger situation where I was describing we're going to put a stranger on the street and see how the participant reacts. Just observing, we could say, okay, I'm just going to sit and I'm going to sit and watch someone that's asking for money. And I'm going to say, are the people that walk past that individual, are they men versus women? And who helps more often? That would be observational. And you can also do surveys that you could kind of get a general understanding of how people are responding. But there are issues because maybe I'm looking at a certain street where I'm making this observation, but it's in a really wealthy area, and this particular demographic isn't likely to help the stranger. So it would be inaccurate for me to say, I did this study and now I know how people behave. They're never going to help strangers because what I saw, they didn't help strangers. That isn't inaccurate. You couldn't generalize it that big. There's observer biases, which you can try and address with inter-rater reliability, but there are some issues with just having a biased observer, and you can't test cause and effect. And then there's correlational. Correlational is going to compare 2 things at the same time. How does one thing relate to another thing? Height and weight are a good example of a positive correlation. So things that increase together. Individuals that are taller are more likely to have a higher weight. They have more bone and more fat and more muscle as they are taller. But that doesn't necessarily mean that every tall person also weighs a lot. You might find a tall person that's really skinny and a tall person that weighs more. So you can kind of see this positive correlation. It's really likely that a taller person weighs more. So as height increases in a population, weight also is increasing. And so we say that is a positive correlation. Height increases, weight increases. That can be the statistic that people would use would have a strength. And you would say it is between -1 and +1. This is kind of nitty gritty, but could show up and might be interesting. The point is to say they have different strengths. So a a correlation of +1 means that for every person that is taller, every person weighs more. There are very few like +1 correlations that exist. Usually things are in the plus 0.2, 0.3, 0.4. For this height and weight one, it's a pretty strong, like 0.8, 0.9 correlation, which just means it's pretty strong. Most people who are taller weigh more. Then there's this hours of sleep compared with tiredness. We can see it's negative. As you get more sleep, you are less tired. So an increase in hours of sleep is associated with a decrease in tiredness. But this one seems a little less strong. So this is negative because it's as one increases, one decreases. And it's less strong, so it's maybe 0.4, negative 0.4, negative 0.5, meaning some people don't feel that tired even if they don't get that much sleep. I might get 7 hours of sleep or 6 hours of sleep, but I feel okay. It would be if I get 5 hours of sleep. I feel dead to the world. But it's probable that someone who gets 8 or 9 hours of sleep feels way less tired. So more sleep leads to less tiredness, but it's not always a perfect association. And then we see one that is shoe size and hours of sleep. This has no correlation. It would be a correlation of 0. Shoe size has no real impact on the hours of sleep that you're getting. And hours of sleep has no real impact on shoe size, right? I'm a size 10, but I get different hours of sleep each night. And there are other people with size shoe size 10 who get different hours of sleep, right? So shoe size and hours of sleep not really connected. So it's not going to have a correlation. Here's one that you can test yourself. Answer is in the slides. But there are limits to correlational research as well. A huge thing that you will always hear psychologists and others saying is correlation does not equal causation. Just because two things are correlated does not mean that one is causing the other. The most classic example is shark attacks and ice cream sales. These are positively correlated. Ice cream sales increase at the same time that shark attacks are increasing. Is it true that ice cream sales are causing shark attacks, or that shark attacks are causing ice cream sales? No, they are associated with a confounding variable, something else that's going on, which in this case is the fact that it's summer, right? During the summer, people are by the beach. They might get attacked by a shark. People like things that are cold, so they eat ice cream. These things are correlated. The number of shark attacks and ice cream increase at the same time during the summer, but one is not causing the other. Another example might be the activity level of raccoons and people. Raccoons are nocturnal. They come out during the night. People are, I think it's called diurnal. They are asleep during the night. So these are negatively correlated. Raccoons' activity increases while human activity decreases. But one does not cause the other. Humans are not decreasing their activity because raccoons are increasing their activity. These just happen to be occurring together. So it's important to look at that, right, when designing these studies. If you want to test studying and test outcomes, does studying cause increased test scores, or do they just happen to be associated? You would design an experiment. With an experiment, you, on a basic level, would have two groups, experimental group and control group. Random samples, so you just gather a bunch of people. You don't want to be biased by just saying, oh, I'm just going to pick a group of rich white men, you get a random selection of people that is ideally representing a larger population. So say you want to know something about college students in general. You don't want to just look at one university. Let's get college students at a community college, at a private university, at a public university. Let's get all college students, equal men, equal women, and assign them to different groups. So I assign one group, I want you to study for 5 hours. For the other, I want you to study for 10 hours. Or maybe you have a new technique because we're talking about experimental versus control. So let's say I have developed the Dan method of studying. I'm going to assign 100 college students to use the Dan method. That is my new experimental group. And I want a different 100 students in the control group. You guys study how you've always studied. Don't change anything. You're control. I think my experimental group is going to probably perform best. I've developed this really awesome studying method, and I'm going to test it to prove to everyone that my studying method's the best. We can then compare those groups and see whose outcomes are the best. One potential limitation is that it might be too controlled. If I'm doing something in a research lab, maybe it's not actually reflecting reality. Or maybe I say, you have to use my method and use it at least 1 hour a day. But in reality, maybe people aren't studying for 1 hour a day. So it might be a little too controlled to say, yeah, this really applies in the real world, but a potential risk. We then think about independent and dependent variables. So what is the thing that we're changing and what is the outcome? So the independent variable is the thing that you change, right? And this is stuff that, I mean, if this is the general scientific method, you may have heard about this before. The independent variable is the thing that you're changing, right? So this is going to be the studying program. Dan's studying program or study as usual. The dependent variable is the outcome. What's the thing that I'm measuring? Let's pick test score. How does the independent variable affect the dependent variable? So you might say an independent variable is type of television programming viewed. How does that impact violent behavior displayed? Does it impact? Does that observation lead to changes in behavior? Maybe. Is it only true for boys versus girls? Maybe do a new experiment or look at that breakdown. This is a check to see, kind of check what those differences are. So think about which of these describes descriptive versus correlational and experimental research. So A is looking at, this is the only way to determine if a cause and effect relationship exists between variables. B is thinking about, this allows researchers to gather more information about a topic. And C is tests a hypothesis to determine whether a relationship exists between two or more variables. So that is going to be experimental, descriptive, and correlational here. Thinking about the experimental, a key idea is that cause and effect. Descriptive is like observational. You have noticed something, it might inform a future study, but it's not that compelling to say it is a psychological truth. And then correlational is going to be looking at these relationships between two, but not determining cause and effect. This is an application of all this stuff that we've talked about. For example, interpreting research. If you have an idea, you propose a hypothesis that a standing desk increases productivity. Maybe you've observed, you have a friend who says, oh, I just got a standing desk. I'm so productive now. Is it true that the standing desk is causing increased productivity? Well, let's design it. We'll have one group, 1,000 people, they'll use a standing desk. We'll have 1,000 people that don't. They'll use their regular desk or a specifically non-standing desk. We'll assign them randomly and we'll give them a typing task to see, are they more productive? There are 3 options here. We could see that the results support the hypothesis, right? That's what we are seeing. We observed that, let's say the blue people are the people that were most productive, and they were using the standing desk. So blue is standing desk, red is no standing desk. This circle is showing our sample. But what if we looked at it wrong? What if it wasn't the full picture? What if we had a bigger sample, we had 10,000 people, we would have seen that actually a lot of the red people are more productive than the blue people. People without a standing desk, if we had observed more people, no standing desk is actually more productive, or it really just didn't make a difference. So we have alternatives. We could say results support the hypothesis, standing desk makes you more productive. We could see the opposite, that sitting was actually better than standing, or we could just see no difference. We have to ideally find kind of these representative populations to make a conclusion, but we can use statistics to make these conclusions. We, in psychology, can use these statistics based on distributions. This is getting into the very nitty-gritty. Is not the most important about general psychology, but is something you will see in research. Data vary. More specifically, values of a variable vary, which is to say those outcomes, right? Test scores are going to vary. We can analyze the pattern of variation called the distribution of the variable. And you can look at things like averages and medians or go beyond those. We can then begin by looking visually. Tables and graphs are presented in mass media, sometimes accurately, sometimes not. This is maybe one of the key things that you can take away from this section, which is to be an informed observer and consumer of news. These graphs technically say the same thing. they say that group A had an average of 7.5 on something, and group B had an average of 6.5. But it looks way more dramatic than it really is. And you see this a lot in like politics. You see, like in the polls, one candidate looks like they have way higher odds of winning the election, but it's only like 33 versus 35% support. So a certain organization can be biased by showing one kind of more dramatic graph. So the most accurate way would be to do the way on the right, right? They're an equal scale from 0 to 8 and showing the data, whereas it looks so much more dramatic and is sort of misrepresenting the data by doing it the way on the left. This statistical significance piece is how you can make these official conclusions. What we do is run our data through these statistical tests and use a p-value to determine how often a random process would give a result at least as extreme as what was found in the actual study, assuming there was nothing other than random chance at play. So this is crazy. And I'll spend a moment on it, but you don't have to get hung up on it. It's just, it is in the textbook if you want to dive deeper into it. It is just something to understand that we are trying to make these official conclusions, right? So thinking back to this difference here, if I have 10 people in my study, I assign 5 people to a standing desk, 5 people to a traditional desk, and say, let's see how they compare. And our results, we saw most of the people with the standing desk performed better. But it seems like the sample that we observed, that happened by chance. In this universal truth world, that is the gray outside circle, we are observing sitting was actually more productive. So how do we know if we have too small of a sample and stuff is happening by chance? What we do is we are going to use these statistics. How certain can we be? As psychologists, we try to be 95% sure. 5% of the time, we are accepting we could be wrong, and we just observed something by chance. But we try to be 95% sure that we are correct, or otherwise we would say, we aren't sure what's going on. But if we're 95% sure, we run these statistics, and let's say on this typing task, the standing desk group does phenomenally better on the typing task. Standing desk gets 100%, seated gets 20%. Those are so different that you would test it, you would run these statistics, and the statistics would pop out and say, we are more than 95% sure that this happened because of the thing that you did, the thing that you manipulated. We are 95% sure or more that the independent variable, the thing that you manipulated, led to that outcome. It wasn't random. But if we are 94% or anything, we say, well, it wasn't because of the thing that I did, something else was going on. So that is how we make these more official conclusions by using this p-value. The p-value is the probability, basically, that something is random or not random. So if the p-value is 95%, the p-value tells you how often a random process would give a result at least as extreme as what was found in the actual study, assuming there was nothing other than random chance at play. So would it be, so if only chance was going on, we are fine if chance suggests that that happens 5% of the time. I will leave you with this by saying it's not that important at this point if you take it away. It is really nuanced and complicated. The key takeaway is that there's math that we can say, oh, this group averaged 10, this group averaged 8. Let's compare those and see if there is an official mathematical difference between these and say, this is like, we are 95% sure this wasn't based on chance. There's a 5% chance that it was random, that we got those results, but we are 95% sure that this happened because of the thing that we did. This is about writing research. You'll notice if you come across research articles, there are key components. That is writing an abstract, a summary of your finding, the introduction, the background, what stuff do we know so far? Why did I even come up with this experiment? What were the methods that I used? Where did I get my participants? What was the task that I had them do? What are the results? What did I find? And what's the discussion? What is the implication? What does this mean? Why was this even important? How is it similar or different from previous research? That is a basic level of the research process and the research setup, system, reporting. And then one last thing is to talk about the replication crisis. This is related to the weird studies that we've talked about, right? Even though we are saying the things that we find are based in reality, it's not just chance. A lot of times when research has been done again, we find that it doesn't hold up. A lot of times that's because methods have been unclear or because it was done in a specific population. So maybe I did a study, but I wasn't super clear about the setup that I had. Or, for example, like in the standing desk problem, is it a certain height? Maybe in the way that I reported my study, I wasn't clear that it had to be at chest height. Maybe a different researcher might run that same experiment, but they might run the study so it's lower. And so we have a problem because the study didn't replicate. They didn't find the same results. This is actually super common. Researchers will replicate a study and find that it doesn't hold up. They didn't find the same thing. Maybe that's, again, maybe it's cultural. Maybe they did a study and it was all with women, and then they find it doesn't replicate in men. So there are a bunch of reasons for this, right? Some things are up to chance. We're accepting that 5% of results could be random and we might be wrong, but we're leaving that up to chance. There might be bias. People might kind of lie or just find something that does look accurate and kind of lie about it. They might straight up lie about their results, falsify them. Maybe times have changed. Maybe you did a study, you were looking at um, um, opinions on global warming. And 100 years ago, if you did that study, people maybe wouldn't fear about global warming. But now, if you did an experiment, you might see that people do care more about global warming. So maybe times have changed. And maybe there's poor replication. Maybe the next study has been worse, not well replicated. In those scenarios, you might find different results. And so that is why psychology is a science. It is constantly changing, replicating these studies, trying to be more accurate, finding gaps in research, and continuing to strengthen the field. There's this video. If you are interested, I'll leave it. Feel free to go through it, but not a requirement. The key next will be to find psychology out in the world. Take away some of these key messages, right? Think about general ideas. What is psychology? Are there some key figures? How did we get to where we are today? What are those main domains? What are these future things that we're going to be looking at piece by piece to understand humans, to understand psychology? And about those research pieces, right? Those key pieces. How do we study psychology? How do we design experiments? What is an experiment? Those key pieces. And then there are those additional details in between, which can be helpful or interesting, but are not always most essential at this stage. Do the discussion assignment, write your first description, discussion post, find psychology in the world. You don't have to respond to someone else until next week. And do the first quiz. Let me know if you have any questions, concerns. Happy to answer questions. And apart from that, I hope this was informative, interesting, and I hope that the rest of the course is enjoyable. I think some of the assignments are pretty fun, and yeah, I think a lot of the content is very interesting. Have a good rest of your week, and welcome to the class. Bye.